In this video, I'm going to be talking about the topic of super strong fine-tuning evidence for God. I find this type of evidence to be, well, super strong, and I hope that you will too. Um, so, before we jump in, let me tell you where I'm planning to go in this video. I'm going to begin with talking about why I'm so interested in scientific evidence for God, and I think some of you will relate to this. Um, what is fine tuning, basically? And then I will share fine tuning of the fundamental forces of physics, focusing on the example of gravity. A practical example really helps, I hope, I think, really helps people to get what we mean by fine tuning. And then I'll talk about some other examples of fine tuning. Um, and then why I believe this fine tuning thing is true, that there really is fine tuning for life in our universe, and 4 helpful books on this topic if you want to read and learn more. I'll address the issue of what about the multiverse. The multiverse is, in my thinking, the main alternative argument, the main counter argument to the ideal that fine tuning indicates that there is a great creator. So I'll talk about the multiverse a little bit. Why fine tuning is such a powerful evidence for God. I want to talk about that some, kind of summing things up. That will kind of be all through the video, but kind of summing it up at the end. And then why you should spend time on this and a couple of kind of practical applications at the end of the video here. Uh, so before we jump into the scientific evidence and arguments, you might wonder why a pastor at a small country church is talking about science and if I even know the difference between a neutron and a proton. I am a pastor at a small country church, and I thank God for the opportunity to serve here and the wonderful people who I worship the Lord with and serve together with. They're really a great group of people that none of us are perfect, but they love each other and love their neighbors. Why am I especially interested in scientific aspects of this evidence, of evidence in nature? So I have a whole series. This video is part 5B in a whole series of videos talking about why I believe in God, the types of evidence that are important to me. And of the different types of evidence, the one that I have spent the most time thinking and studying about is specifically scientific evidence. Now, I am not saying that scientific evidence is more important than the other categories that I mentioned in this series of videos, but I've spent the most time on it. That's all I'm saying. And why am I so interested in this? Well, here's some reasons. One is just that I like science. I always have. I loved science. I remember as a kid, I think I was just in elementary school. I'm almost sure I was. And I remember getting a book from the library that was about atoms and explained protons and neutrons and electrons. And boy, I was just fascinated by it, and I always have been. So it's not surprising that I got my Bachelor of Science degree in mechanical engineering. Mechanical engineering, in your first year or two, you have some basic science classes and math classes, a couple of semesters of physics, a couple of semesters of chemistry, 3 semesters of calculus, a semester of differential equations. But then those engineering classes that take up a lot of the rest of the curriculum are mostly more advanced applications and more specific applied studies of the basic physics principles. So things like thermodynamics and heat transfer and statics and dynamics, systems that are not moving and systems that are, and the forces involved in them, and energy systems, all of that type of stuff. I studied, I loved it, I enjoyed it, I did well in it, but by God's grace. Then I went in the Navy. I had a Navy RTC scholarship to pay for my undergraduate degree. And in the Navy, I studied nuclear engineering. So it's a competitive program to get into the nuclear engineering part of the Navy. most of the people who were in the nuclear power school with me were in like either the top 5 or 10% of their engineering or math or science curriculums in universities around the country. And then we had a year of intense additional study, specifically about nuclear engineering. And then I served. So I was in the Navy for 5.5 years. I served in the engineering department of nuclear submarines for about 4 years. So I was thinking about physics and science and nuclear stuff all the time. Then later, I had a chance to teach thermodynamics and heat transfer classes at a university. Now, I actually have 2 master's degrees. One is in Indonesian language, and the other is in a master's of divinity, where I studied Greek and Hebrew and theology and the Bible, all that kind of stuff. But normally, you need at least a master's degree in order to, in the field that you're teaching in, to teach undergraduate classes. And I only have a undergraduate degree, a Bachelor of Science in engineering. But the university I was teaching at, it was overseas, and all of their classes, not all, but most of their classes were team taught. So they had 2 professors. And so I was teamed up with professors who had PhDs in, typically in engineering. But they let me do a lot of the teaching because thermodynamics and heat transfer were topics that were very relevant to the nuclear engineering that I had actually done. And so I loved teaching these classes and helping students to understand these topics. And then later on, I got to teach my own daughter chemistry, physics, and 2 years of calculus. She was really good at math in homeschool, in high school homeschool. So studying about scientific evidence for God has been an intellectual hobby for about 25 years, but it's a hobby that's very meaningful to me. And so I've read stacks of books. I'm going to mention 4 books specifically related to fine-tuning in a little bit, but I've read stacks of books on this topic. I've written a number of blog posts on scientific evidence for God. I will try to remember to give a link to, I have one blog post where I have a collection of all of my blog posts that are related to scientific evidence for God. I'll provide a link for that in the description for this video. So I've spent a lot of time thinking and reading and studying and teaching others on this topic. God is the most important reality in my life, so it makes sense that I would combine my love for science with my belief and my faith and my love for God, and that I'm really interested in scientific evidence for God. I also feel like it's tragic. It is a tragedy. It is tragic that many people list science as a reason they reject belief in God. And I've always felt so sad whenever I see that, because for me, it's just the opposite. For me, scientific evidence and scientific reasoning strengthen my faith in God. And so now let's talk about the fine-tuning argument for God, which is one of the types of scientific evidence for God. So here we go. What is fine-tuning? Fine-tuning refers to discoveries in physics and cosmology. Cosmology is the study of the universe and how the universe got here, in the history of the universe, and how it is the structure of the universe at a very large level. So it's discoveries in physics and cosmology that indicate that there are fundamental constants in physics and initial conditions in our universe that must have very precise values, and they have these very precise values are the values that they actually do have in order to allow our universe to be life permitting. Now, what do we mean when we say life permitting? Well, in order for so we can imagine other theoretical universes that would be different from ours, and for any universe to have life, we're talking about physical life. I'm not talking about the possibility of angels and demons. I believe those things are real, but that's not what I'm talking about here. I'm talking about physical life, biological life. There's some things that are non-negotiable, and scientists. This is not controversial. Okay, we need stars. The sun is a star, um, and for instance, life on Earth, almost all life on Earth gets we get our energy from starlight. In our case, the light from our sun. Um, Plants, of course, do photosynthesis where they directly use sunlight to produce the chemical energy they need. And then all other creatures that don't do that, uh, we either eat the plants or we eat animals that eat the plants. So we need stars for that reason, but we also need long-lived, stable stars. It wouldn't work if the star was only around for a few years, or even a few thousand years would not be enough. And then the third one is less obvious. We need stars uh, that produce uh, all the elements of life beyond hydrogen and helium, and that expel these elements into the universe where they can be included in planets that then can host life. For example, we need oxygen and carbon for life. So, the best scientific theories today indicate that hydrogen and helium were formed um, during what we call the Big Bang, early in that process. But that all of the heavier elements are formed inside of stars through nuclear fusion. And then some of these stars explode very violently, and they expel these elements. And then these elements in glass clouds and nebulas, some of them can coalesce into new stars, but some of them coalesce into planets, like the planet Earth. And without oxygen and carbon, there's no possibility we could have life. Now, you might think the first thing you think about when you think about oxygen is the fact that me and you breathe oxygen, but there are types of life that do not breathe oxygen. But remember, all life needs water. Every single living thing that we have ever discovered or that we can realistically imagine needs water to live, from bacteria to elephants to flowers. Everything is the chemistry inside every cell is in a solution of water, and water is H2O. Water needs oxygen. Then we also need carbon. Every single cell in every living creature, from bacteria to hummingbirds, has a lot of chemicals in it: DNA, RNA, proteins, sugars that are all carbon based. And there is no good substitute for carbon or oxygen. These are not the only two elements we need, but we need stars that can make these elements. So when we say a life permitting universe, we're talking about a universe that, not a universe that would automatically create life, but a universe where there's at least some possibility for life because there are stable stars and we have the chemicals that we need to make life. Okay, so here's an analogy that will help us understand this fine-tuning, how this is evidence for God. If someone buys just one lottery ticket and wins the lottery, they are very lucky. But we don't have a strong reason to suspect that the lottery was rigged. That is lucky, but it's not so lucky that you say, well, it's practically impossible. It's just lucky but not impossible. But if someone buys just one ticket each time and wins the lottery 10 times in a row, or really, if you do the math, even if they only won 2 or 3 times in a row, buying just one lottery ticket each time, and I'm talking about a lottery like the Powerball lottery, people would be justified in suspecting that the lottery was rigged. People would be right to demand an investigation. It would be far more likely that the lottery was rigged, that someone intentionally manipulated things so that that person would win 2 or 3 times or 10 times in a row than that they just got lucky. Now, the situation in our universe with regard to the laws of physics and initial conditions are more like a person buying just one ticket each time and winning the lottery hundreds or even thousands of times in a row, and no one gets that lucky. Now, what am I talking about? So what I'm saying is that just like we would suspect that someone rigged the lottery to allow somebody to win more than one time in a row, we have good reason to suspect that someone, a capital S someone, God, rigged physics in the initial conditions of the universe to allow for life. Now, to understand why this is true, let's begin by looking at the four fundamental constants in the universe. The four fundamental forces in the universe. Each force has a constant that is associated with it. And, there are lots of forces in the universe, but they all boil down to, our current understanding of physics indicate that they all boil down to just four forces. And we are going to start with the force that we are most familiar with because it's easiest to think about this force as an example, namely the force of gravity. So here we go. Here's a formula for gravity. And now this is Newton's formula for gravity. Einstein has a formula for gravity that actually is more precisely correct, but both formulas have this G in them, so that doesn't change. So we're going to use the easier formula, which applies in the vast majority of situations you would think about for gravity. And we're gonna talk about this fine-tuning issue by looking at gravity. So the way this formula works is F stands for force, and here is specifically the force of gravity. For instance, we could be calculating the force of gravity that the Earth has on the moon. And we would need to know M1 and M2. That would be the mass of the Earth. How much does the Earth weigh? Or, I prefer to work in SI units. So how many kilograms is the Earth? How many kilograms is the moon? That would be M2. R is the distance between the Earth and the moon, and that's squared, the distance squared. But then, but all of that, those three pieces of information is not enough to know the force of gravity. We also need this, G. G is the gravitational constant. And this is what G is equal to. It's equal to 6.67 times 10 to the negative 11th Newton meter squared per kilogram squared. So this is basically the strength of gravity. You can think of the constant G as being the strength of gravity. And physicists have asked an interesting question, physicists and cosmologists. What if it had been different? Now, here's the interesting thing about G. It's a constant. That means it's the same everywhere in the universe, and it's always been the same. It's been the same. It's the same now as it was, 13 billion years ago at the beginning of the universe. It never changes, but there is no known reason in physics that it has to have the value that it has. As far as we know, it could have had a much different value. We don't know why it has this value. We can measure it. We can say it does have this value, but we don't know why. Now, to think about the different values that this gravity might have had, it would be helpful to compare gravity to the other four fundamental forces in physics. So after gravity, the next stronger force, gravity is the weakest of the four forces, and we're going to say gravity has a strength of 1. Now, I just showed you a different number that's not 1, but let's make a unit that is equal to where one gravity strength unit equals 6.67 times 10 to the negative 11th Newton meter squared per kilogram squared. This will make it much easier for us to compare the strength of gravity to the other forces. and we're going to call it a strength of 1, in which case the weak nuclear force is 10 to the 25th times stronger. So it would be 1 times 10 to the 25th would be a constant that tells us how strong the weak nuclear force is. And so it's funny that it's called the weak nuclear force, but it's massively stronger than gravity, but it's a lot weaker than the strong nuclear force that we'll get to in a minute. And this number, 10 to the 25th, is just huge. I mean, a million is 10 to the 6th, a billion is 10 to the 9th, a trillion is 10 to the 12th. So this is more than a trillion trillions. This is a huge amount more powerful than gravity. And then the next stronger force is one we're a little bit more familiar with, similar to being familiar with gravity, is the electromagnetic force. So if you have two magnets and you have a north pole and a north pole, those will repel each other, but a north pole and a south pole will attract each other. How strongly do they attract or repel each other? The same is true if you have two positive charges. They repel two negative, but a positive and a negative would attract. And this force is way more powerful, way more strong than the weak nuclear force by 11 orders of magnitude. So that's more than 1 billion times stronger than the weak nuclear, which is 10 to the 25th times stronger than gravity. And then finally we get to the strong nuclear force. Whew! It's another 12 orders of magnitude. Another, that would be what? Another trillion times. No, I'm sorry, just 100 times stronger than the electromagnetic force, but about a trillion times stronger than the weak nuclear force is the strong nuclear force. Now, what does a strong nuclear force do? It holds together protons and neutrons inside the nucleus of an atom. So two protons are both positive. So they're pushing each other apart. So how do they stick together inside the nucleus? Well, the electromagnetic force is pushing them apart, but the strong nuclear force is holding them together, and it's even more powerful than the electromagnetic force. But the strong nuclear force doesn't reach very far. It only affects things that are very, very close together, like two protons in the nucleus of an atom. In fact, the way that scientists measure the relative strength of these forces is they looked for a situation where all four forces were at play. And the situation they picked was two protons in the nucleus of an atom. Those two protons do have mass, so they're pulling on each other gravitationally, but that gravitational force is so weak compared to the other forces that you can just ignore it. You can't ignore it if you're jumping off a building. Gravity will kill you. But if you were two protons in an atom, you could ignore it because it's so tiny compared to the other forces. Then the weak nuclear force, this is a force that has to do with a certain type of radioactive decay. It's the least intuitive force, how it works. The electromagnetic force, those two protons are both positively charged, so they are feeling an electromagnetic force that's trying to push them apart. But the strong nuclear force they are also feeling, and that strong nuclear force is causing those protons to stay stuck together in the nucleus of an atom. Now, if you split that atom, like we do in nuclear reactors, then some of that strong nuclear force gets released in kinetic energy, and that's why nuclear power is so powerful, because it's working with such a strong, powerful force. Okay, now excuse me, I'm gonna use a cough drop here. I have allergies and my throat's a little bothered, so I apologize if you hear me having this cough drop in my mouth, but it's better than hearing me cough a lot. Okay, so here we have the four forces, and now we get to the fine tuning. Physicists have determined that the value of G, the gravitational constant, is finely tuned to 1 part in 10 to the 35th in relation to a natural range of values that G could have. So physicists look at this and they say, we have no idea why gravity has a strength of 1, but the nuclear force, the strong nuclear force, is 10 to the 38th times more strong. As far as we know, based on all of the physics we have, gravity could have been equally strong to the strong nuclear force. But it turns out that if gravity had a strength that was just a little bit different than the strength it actually does have, then there could be no life in the universe we live in. If gravity was too weak, it would be much harder for stars to form at all. Gravity causes hydrogen and helium gas to collect into a star, but the pressure from all that gas being together is trying to blow the star apart. And so gravity has to be strong enough to collect the gas at a big, huge, giant ball of gas, hugely more massive than the planet Earth, has to hold together by gravity to create enough pressure inside the star to cause nuclear fusion to happen. So if gravity was too weak, it would be much harder for stars to form at all, and even those stars that did form would not produce carbon. No carbon, no life. So that's what would happen if gravity was too weak. What would happen if gravity was too strong? It would be easier actually to make stars in galaxies in the universe. But if gravity was too strong, stars would burn up too quickly. If it was strong enough, a star could burn up in just a few years. So it would burn up too quickly to support life and would only expel elements heavier than carbon and oxygen. So it would produce carbon and oxygen, but those elements would never get out of the inside of the star. And so we would not be able to have any life. There are other issues with gravity needing to have the value it does as well. So again, physicists have determined that the value of gravity is finely tuned to 1 part in 10 to the 35th. Now let's think about what that means. The chance of buying 1 ticket and winning the Powerball lottery. By the way, I personally don't play the lottery at all, but you know, a lot of people do. So the chance of buying 1 ticket and winning the Powerball lottery is 1 in 292,201,338, which is about 3 times 10 to the 8th. But the odds of getting a life-permitting value for the strength of gravity, if we just assume, which seems like a very reasonable assumption, that it could have had any strength between 0 and the strong nuclear force. In fact, you could assume that it could be even stronger than the strong nuclear force. There's no reason we know of it couldn't have been. But if you just pick a reasonable range of values based on the other forces, it's this huge number, which is 1 times 10 to the 35th. So you would have a better chance of buying 1 ticket each time and winning the Powerball lottery 3 times in a row than you would of getting the right value for the gravitational constant to allow life. But that is only considering gravity. Just like in Powerball, you have to choose all the correct balls. The number, I think there's 6 balls, 5 white balls and 1 red one. You have to get all of the right numbers in order to win. In order to get a life-permitting universe, you need finely tuned values for all the fundamental forces. So all 4 fundamental forces must have roughly the strengths that they actually do have in order to have a life-permitting universe. And I'm not going to explain what happens with all the other forces if they're wrong, but really devastating things happen so that we could have no life in the universe at all. Now, the 4 fundamental forces of nature are not the only things in physics that are fine-tuned. The masses of elementary particles like quarks, like the up quark and the down quark, and electrons are also fine-tuned. Um, so now I'm not going to talk about the elementary particles. That adds more fine-tuning, but I do want to talk about something else. Some of the most amazing and mind-blowing levels of fine-tuning have to do with aspects of physics in our universe that are a bit less intuitive and less easy to understand than the strength of forces or the mass of particles. Um, so the cosmological constant is one of these. The cosmological constant is a fundamental constant in physics, similar to the constants that go along with the four forces of nature. Uh, Physicists now commonly agree that the degree of fine-tuning for the cosmological constant is no less than 1 part in 10 to the 90th. 10 to the 90th. I believe that is more than the estimate for the number of particles in the entire observable universe. Then all of the atoms, all of the neutrons and protons in all of the galaxies that we could see if we had really powerful telescopes looking all over the galaxy. It is a super huge number. You can't get that lucky. What does the cosmological constant mean? It's a little bit complicated. It's part of one of Einstein's formulas, but it has to do with the universe expanding, causing the universe to expand, and how quickly it expands. And we have discovered that not only is the universe expanding, but the rate of expansion is accelerating. It's expanding faster and faster over time. And if the cosmological constant was a little bit higher, the universe would have expanded so quickly that no stars or galaxies would have had time to form. Now here's another situation in cosmology. It's one of the initial conditions of the universe that is super fine-tuned. So Edward Penrose calculated an estimate for what may be the most super amazing level of fine-tuning of all. He estimated that the likelihood of the initial distribution of mass energy to have a low enough initial entropy to produce a life-permitting universe is roughly 1 in 10 to the 10 to the 123rd power. Now, this is a 1 with 10 to the 23rd zeros after it. If you had a piece of paper that reached from here to Pluto, and you wrote a 1 and then you started writing zeros after it, and you wrote really tiny zeros, you would not even get close to this number. In fact, you wouldn't get close to this number even if your piece of paper reached all the way to the next galaxy. This is a super huge, mind-blowing number. And what is this with the distribution of mass energy? Well, imagine near the beginning of the universe, let's say, to make this a little bit easy for our brains, imagine relatively near the beginning. You're not even to 1 second into the Big Bang yet, or maybe you're, very, very early. You have a ball, and in this ball is all the mass and energy of the universe. Well, it could be spread out evenly, or it could be in little clumps. And it turns out that due to gravity, the effect of gravity on entropy, that having it more spread out produces a lower entropy, and you need a low entropy to produce a life-permitting universe. And look, I warned you right up front that this is not as intuitive. Entropy is a little bit of a complex topic, but basically, one of the things that would happen if the initial entropy had been higher, and it's much more likely that it would have been higher. If you just take all the possible mass energy distributions, it's far more likely you would have had a higher entropy initial condition. And what that probably would have looked like is a universe full of black holes. Now, I think you can realize that if instead of having a universe full of lots of stars and planets, if you had a universe full of lots of black holes, you couldn't have life in that universe. So this is another example of um, fine tuning in the universe. You would be more likely, far more likely, to win the Powerball lottery a million times in a row if you lived long enough to play that long, than to get all these fine tuning constants to have the right values to produce a life permitting universe by chance. You can't realistically do that by counting on luck. Okay. Why do I believe that the fine tuning is real? After all, I can't do the calculations and verify the math myself. You need a lot of advanced. So I studied physics, but I didn't study very much theoretical advanced physics. So you need a lot of advanced theoretical physics, and you need the computer resources and the mathematical models, these calculations to figure out the, how much these constants are fine-tuned are very advanced types of calculations that the average person, even if you worked as a nuclear engineer for a few years, like I had the opportunity to do, we can't do this math ourselves. So why do I believe that it's correct? Well, as far as I can tell, fine-tuning is widely acknowledged as a real issue among physicists and cosmologists, and I've read on this a lot. Those who don't believe in God don't tend to say there is no fine-tuning. They agree that there's fine-tuning, but they tend to argue that the fine-tuning is explained by the multiverse or something else other than God. So even people who don't believe in God, scientists who have studied this, see that the fine-tuning is real. One of the first scientists to discover fine-tuning was Fred Hoyle. Fred Hoyle was one of the first scientists to find evidence for fine-tuning for life in the universe. He was not a Christian and was just going about his scientific studies, specifically related to studying nucleosynthesis in stars. He was trying to figure out how carbon was made in stars when he stumbled onto something amazing. He realized that some properties of physics had to be precisely fine-tuned for stars to produce carbon, oxygen, and other elements that are needed for life. And he was not a Christian. I don't think he was even a theist to begin with. But after he discovered this, some years later, he made this famous statement. He said, "A common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seems to me so overwhelming as to put this conclusion almost beyond question." So even though, tragically, as far as I know, he never became a Christian, he did believe in this ideal that there had to be a super intellect. Well, this is a super intellect who is capable, who is super smart. He's also powerful enough to change the constants of physics. We can't do that. We can't change the strength of gravity or any of the other fundamental constants in physics. So this force with this super intellect was super smart, super powerful, and ancient. Had to be around at the time of the Big Bang, at least. And so it sure does sound like God to me, and it fits very well with the Christian God, the God of the Bible. Today we're looking at evidence from physics. There's also evidence in chemistry and biology. And the numbers one calculates, he's talking about the types of numbers that I've been sharing with you so far in this video. He says it just seems so obvious that there had to be a super intellect. Now, I've read 4 books on the topic of fine tuning. I want to share these with you because they're part of the reason that I believe in fine tuning, but also you might be interested in reading some of these books if you want to understand this topic more. So the first book is this one, Just 6 Numbers by Martin Rees. It was first published in 19 99. After chapters full of explanations of physics and how our universe is fine-tuned for life, Reed acknowledges that God is one possible explanation. He also is not a Christian. I don't think he's even a theist. He says this: others, that would be people like me, others adduce the tuning of the numbers as evidence for a beneficent creator who formed the universe with the specific intention of producing us. Yes, that's what I believe. I believe that the reason that the constants of physics and the initial conditions of the universe are so magnificently fine-tuned to allow us to live here is because somebody, namely God, wanted to make a home for us, wanted us to live here. But Rees has a different explanation. He says if one doesn't accept the providence argument, in other words, if one doesn't believe in God, and he doesn't give any reason that he rejects that argument, he just says, well, if you don't believe in it, then he says, well, another possibility is the multiverse. And I'll explain in a little bit why I do not agree that the multiverse is a good explanation for fine-tuning. The next book I read on this topic was this one, The Goldilocks Enigma. Why is the universe just right for life? And it should be obvious why the title, The Goldilocks Enigma, is appropriate. It's like Goldilocks had the porridge that was not too cold and not too hot. It was just right. And the constants of physics and the initial conditions of the universe are just right to allow us to live here. And so he wrote this book. He also is not a Christian. I don't think he's even a theist. But he says near the end of the book, both of these guys have wonderful explanations of the physics and cosmology. I enjoyed reading the books. Near the end of the book, he says, I can see that the universe at least appears to be designed with a high level of ingenuity. So he's saying, it sure does look like some kind of a great designer made all of this, but he prefers a different explanation. He prefers some type of vague life principle that we haven't really discovered or understand yet that's in the universe, almost like another law, but instead of a law of physics, it would be like a law of life or something, or a self-explaining universe, which may include backward in time causation. That is really weird. It's contrary to everything we know in science and all our experience in life. I can't do something today that will change what happened in the past. But he's saying, well, maybe somehow that could have happened, and an advanced civilization of some type backwards caused the universe to be fine-tuned for life, something like that. I'm not sure exactly. And then the next book I read, this one was published in 2016. Just for the bare science of fine-tuning, this is probably the one I would recommend the most. It's an excellent book, and it's written by two guys who work together. One of them is an atheist and one is a Christian. And most of the book, you can't tell who's writing. They're just explaining the science and the cosmology and the bare fact of fine-tuning. But then near the end of the book, they share their different ideals about what conclusion we should draw from fine-tuning, how we should explain it. So I have a review for this book on my blog post. You can look up this if you want, a review of Fortunate Universe by Lewis and Barnes, and there's the website, the link if you want to read that. And then in my blog post, I made a table. This table is not in the book, but I made a table of the different examples of fine-tuning that they give in the book. Now, this is not all of the examples of fine-tuning they give, but this is some of them. So I'm just going to show you the table here. So here's the beginning of the table. And here it moves up some more. Hold on a minute. Back to the top. Okay. There it is. And here it moves. There's more examples. And there's still even more examples. And even this table is not all of the examples that they give in the book. Okay. Here I am back again. And then, so at the end of the book, A Fortunate Universe, and I loved reading the book. Not only is it very good at explaining the science, but they have a good sense of humor. And I like the heavy duty science. And by the way, all of these books are designed for a popular audience. They're designed for people who are interested in science, but you don't have to have a degree in physics to understand these books. They explain the science for people who are interested in it at a popular level. These two guys, Lewis and Barnes, they also have a good sense of humor. And right in the middle of reading this heavy duty science, I would read something they wrote that was intended to be funny, and it was funny, and I would just laugh out loud. That was kind of nice. Now, at the end of the book, Durant explains several possible explanations that are consistent with atheism and a materialist worldview. So, three explanations he proposes are that either one, further discoveries in physics may explain fine-tuning in a way that does not call for any further explanation beyond the laws of physics themselves. So basically he's saying maybe we'll find out something in the future that will explain it all and without God. But he doesn't have any idea what that something is, or not any specific ideal. If he had a specific ideal, and it was right, he would win all kind of Nobel Prizes. The second thing is he says the multiverse may exist, and we'll talk about the multiverse more soon, and that maybe that's the explanation of fine-tuning. And the third possibility, he says, is maybe we're living in a computer simulation, and this explains fine-tuning. That sounds really weird. It is really weird, but he's not the only one who has thought about that ideal. But the point is that fine-tuning is so unexpected and so spectacular that there has to be some kind of an amazing explanation. One amazing explanation is God, or else you have to think of one of these other really unusual explanations. Now Luke, the other guy who wrote the book here, then gives the answer that I'm convinced is correct. Fine-tuning is strong evidence that a wise, powerful creator is responsible for establishing the laws of nature and for making a universe that can support life. In other words, our universe is fine-tuned for life because it was intended and planned to be our home. So that makes the most sense to me. And then the fourth book, I've saved the best for last. So here it is, Return of the God Hypothesis by Stephen Meyer. This book is, if you only have time to read one book on scientific evidence for God, read this book. It is awesome. Meyer is a great communicator. He is brilliant. He is insightful. I highly recommend it. It's a new book, so it has and it's very heavily documented. Lots of research went into the book, and it just came out this year, so it has all of the newest issues and controversies and scientific arguments. I also have a blog post on this book, not on the whole book, but on the God versus the multiverse issue. One of the reasons I recommend this book the most, Return of the God Hypothesis, is because he goes into the most depth of explaining the alternative explanations for fine-tuning and the other evidence for God. He gives two other types of evidence, scientific evidence for God, in addition to fine-tuning. And he talks about the alternative explanations and why belief in God is the very best explanation. And he goes into a lot of depth, and he takes these things seriously. Now, this leads us to the question of why not the multiverse? So what some people have said is they've said, okay, if there's only one universe and we happen to have the right constants for physics in the right initial conditions, that is so unlikely, so super astronomically unlikely, that it's true that would seem to indicate that maybe, God existed and planned the whole thing. But they say maybe there's another possibility. Maybe we're not the only universe. This would be like if you were playing the lottery, and instead of buying one ticket every time you played the lottery, you bought maybe 100 billion tickets or 200 million tickets or something. Then your chances of winning would go up. And in fact, if you bought enough tickets, you would be sure to win. Now, the cost of the tickets would be more than what you would win, so it wouldn't be worth it. But the point is, what they say is, what if there's a whole bunch of universes, and we call all of these different universes together the multiverse, and each of these universes has different values for the laws the constants of physics and different initial conditions. And let's say that there's a super huge amount of these universes. All of a sudden, it becomes likely that one of them would be life permitting, and of course, that's the one we live in because we can't live in the other ones. Um, and, uh, and so this is now right away you may be thinking, whoa, why we can't see these other universes? Not only it's not just that we don't have a powerful enough telescope. No matter how powerful a telescope we make, we'll never be able to see any of these other universes. It's extremely unlikely that we would ever have any type of observational evidence, direct evidence for these other universes. There isn't good evidence for them now. It's all theoretical, and I think the reason that people came up with this idea, or at least the reason it became popular, is largely to offer a counter explanation to the possibility of God creating the universe. Now, Meyer, in his book, he gives a number of reasons. I'm going to give 4 of them here that the multiverse is not a good explanation for fine-tuning. Number 1, the principle of Occam's razor states that when attempting to explain phenomena, we should, as much as possible, avoid multiplying theoretical entities. So, long before we knew about fine-tuning, lots and lots of people believed in a God who was powerful and wise enough to account for fine-tuning, even though we didn't know that fine-tuning was a thing yet. Still, that requires belief in one entity that we can't directly absorb. We can see lots of indirect evidence for God, and this whole video series gives different types of that evidence. But it's true that we can't see God directly, but the multiverse requires believing in many other theoretical entities. And I'm not just talking about believing in all these other universes we can't see. In order to explain where these universes came from, multiverse theories involve believing in other things like string theory and a inflationary field that is generating these other universes. None of these things have been even remotely proven. We can't see any of them. There's not evidence for these things. So why believe in all of these other things instead of believing in God? His second reason for preferring God over the multiverse is that we should prefer explanations that match what we already know about the causal powers of various kinds of entities. So we know that intelligent beings can fine-tune things. People can fine-tune things. We can't fine-tune the universe, but we can fine-tune a lot of things to get them to do what we want them to do. I'll mention more about that in a minute. But we have no experience with a multiverse generating mechanism fine-tuning anything. So just based on that, picking an intelligent being as the cause of fine-tuning makes more sense. Number 3 is perhaps the strongest from a purely scientific point of view. The multiverse cannot explain fine-tuning because the various mechanisms proposed for causing the multiverse themselves would require a huge amount of fine-tuning. So it's just moving the problem back a step. Now, you say, well, why is that so? That's a big topic, and he explains it in depth in the book. So I encourage you to read the book. I explain it a little bit in my blog post about the book, if you want to read that blog post. Number 4, the cosmological models, inflationary cosmology and the string landscape that the multiverse generating mechanisms are based on might not even be correct. This is theoretical physics that hasn't been proven, and there's a lot of physicists who don't think that these things are correct. But if these things aren't correct, then they have no idea how there could be a multiverse or how it could create different universes with different physical constants and different initial conditions. This is their best guess, and they have no idea if this guess is matching reality in any way. So God is a much better explanation. So why is fine-tuning such powerful evidence for God? Summing things up, intelligent agents can fine-tune things to get a desired result. An example is all the instruments in an orchestra being finely tuned to produce beautiful music. If all the tuning knobs were just randomly turned around, you would have a mess. But intelligent people can fine-tune them. Another example is dialing one of approximately 10 billion telephone numbers to talk to the exact person you want to talk to. Intelligent agents do fine-tuning types of things all the time. So having a super intelligent agent to do super fine-tuning makes good sense. Nature, if you don't believe in God from an atheistic point of view, you're just talking about matter, energy, space, and time, is incapable of choosing among a vast range of possibilities, like the values of the gravitational constant, in order to achieve a goal such as life, because nature is not intelligent. Atoms and galaxies and particles at the beginning of the Big Bang, they don't want anything. They don't want life. And even if they did want it, which they don't, that would be silly, they would not know. They're not intelligent. They would have no ability to choose the right numbers to produce life. Now, to think about this in Bayesian terms, which I like to do as a type of reasoning, abductive reasoning, we could put it like this. It is not at all surprising or strange that the universe is super incredibly fine-tuned for life if the Christian God created the universe. However, it is extremely surprising and unexpected that we, living beings, find ourselves in a universe incredibly fine-tuned for life if a purely materialistic atheistic worldview is correct. We would have expected it not to require super fine-tuning to have a universe that can support life. We would have expected that it would have been much easier to have a life-permitting universe if atheism were true. Therefore, it is far more likely that theism is true than that atheism is true. Getting to the end here, why should you spend time thinking about this? You already have if you made it this far in the video. But why would you maybe buy this book and spend even more time? Well, if you are one of the many, and by the way, I have no financial connection to this book. I just love the book, and I think it's very helpful. That's why I'm mentioning it. If you are one of the many people who up to now have seen science as a reason to reject belief in God, you owe it to yourself to take a look at the very best scientific arguments in favor of God. Because if God is true, and specifically, and I realize that fine-tuning only gets us as far as a great, intelligent, wise, powerful, ancient creator who intended us. That's still not all the way to the specific Christian God. We need other types of evidence that I talk about in other videos in this video series. We need other types of evidence to get specifically to Jesus. But it sure does make Jesus a lot more likely if science supports belief in God. And if Christianity is true, it changes everything. You have the hope of eternal life, your sins being forgiven. All of a sudden, your life has purpose, eternal purpose and meaning. There's a great creator who cares about you. This is a big deal. You owe it to yourself to look at the best scientific evidence for God. Now, if you're already a Christian, looking at the scientific evidence for God can equip you to help others. I also think that it serves as a powerful reminder of the truth of these words of Jesus. Are not 5 sparrows sold for 2 pennies, and not one of them is forgotten before God? Why, even the hairs of your head are all numbered. Fear not, you are of more value than many sparrows. And the point is that God is paying attention to details and things in your life that you don't even know about. You don't know how many hairs are on your head. And the point of this is that God cares about you. And fine-tuning also indicates that God cares about you because he fine-tuned the whole universe to give you a home where you could live. And then it should move you to worship our great creator who fine-tuned the universe for us. Hallelujah. I'm so thankful that our great God knew how to do that and is powerful enough and wanted to make a home for us. 2 possible action items for you. Buy and read Return of the God Hypothesis to get a lot more depth on this topic, or at least read some of my blog posts on the topic. Not as much depth of the book, but more depth on some aspects of this than I put in the video. And number two, share this video with a friend who likes science, and especially if they have thought about the connection between science and faith, between science and God. I want to close with this verse and with a prayer. For his invisible attributes, that is, his eternal power and divine nature, have been clearly seen since the creation of the world, being understood through what he has made. As a result, people are without excuse. Let's pray. Heavenly Father, I thank you that you are a great God, that you are super intelligent, and you knew how to fine-tune the universe for life, and that you are super powerful. You made the right amount of mass and energy, and you organized it in the right way, and worked so that the universe would be a place where we could live. Thank you for making this home that is just right for us. Thank you for helping us to learn enough science to see this additional evidence for how great and powerful and wise you are. I pray that you will use this video for good. Bless the video and bless everyone who watches it. I ask this in Jesus' name. Amen. God bless you.